A grid-tied PV system is designed to work in conjunction with the electrical grid. Its primary goal is to generate electricity from solar panels, power the loads in the house, and supply any excess power to the grid. While the general operation of a grid-tied PV system seems basic, there is a sophisticated set of operations and requirements that govern the operation of the inverter to ensure its safety, performance, and compliance. Grid interactive PV systems must synchronize their output with the utility grid to ensure a smooth and safe transfer of power. This synchronization involves matching the system's voltage, frequency, and phase with that of the grid. Grid interactive PV systems come equipped with various safety features to protect both the system and the grid. Some common safety features include overcurrent protection, overvoltage protection, and ground fault protection. These measures help prevent damage to the system components and ensure safe operation. A grid interactive PV system can also control the flow of power by adjusting the output to match the demand from the load and the grid. The inverter can be programmed to vary its output based on the specific requirements, such as export limitation and demand response modes, typically specified by the local DNSP. An anti-islanding feature is essential to prevent the PV system from continuing to energize the grid during a grid outage. Passive anti-islanding relies on grid voltage and frequency changes to detect grid failure. When the grid fails, the PV system automatically shuts down to avoid any potential hazards for utility workers. Active anti-islanding employs more sophisticated techniques, such as communication with the grid and sending specific signals to detect grid failure accurately. This ensures a faster and more reliable detection of islanding. In addition to the anti-islanding features, secondary protection measures are implemented to enhance system safety. These measures might include additional monitoring of grid parameters and faster disconnection mechanisms. Grid interactive PV systems are typically installed with bidirectional energy meters that measure both the electricity consumed from the grid and the surplus electricity fed back to the grid. This allows the system owner to be compensated for the excess power generated through net metering or other incentive programs.